Intersections part two. We're going to find the point of intersection of two lines, assuming they intersect. It's quite possible that these lines are askew. You could have one line right over top of another. But in this case, they do intersect, and here's how we're going to figure out what that point of intersection is. If they don't intersect, you'd find out in a hurry when we try to do the algebra. Well, first of all, we have them both parameterized with a variable t. But when they intersect, these are really separate variables. So we need to reparameterize one or the other of these using something like s. So let's suppose we reparameterize this one right here and just call this x equals s plus 1, y equals negative 2s plus 2, and z equals negative s plus 3. Well, if they intersect, x equals x, y equals y, z equals z, so we're going to do that. We're going to set t equals this, set 2t equal this, set 3t equal that. And so we have t equals s plus 1. And we also have 2t equals negative 2s plus 2. And we also have 3t equals negative s plus 3. Well, we have three equations, two unknowns. You really only need two equations, two unknowns. So what we're going to do is you can pick any two of these and solve. And I could have picked this one, or this one and this one. It doesn't matter. I'll just pick these two arbitrarily. For one, we have t solved for. So we can substitute in, and you get 2 times s plus 1 is negative 2s plus 2. 2s plus 2 is negative 2s plus 2. Bring the s over here. 4s plus 2 equals 2. 4s equals 0. S equals 0. Okay, now that we have s, we can back substitute into here, for instance. T equals 0 plus 1, which is 1. And so we have t equals 1. If they intersect, this is the ST ordered pair. Now what we need to do is see if this third equation is satisfied. 3t equals negative s plus 3. And keep in mind, you can write s equals 0, t equals 1 to explain what we're doing. Substitute. 3 times 1 equals negative 0 plus 3. 3 equals 3. They do intersect, okay? Now the question is where? I still haven't shown you where. I've simply showed you when s equals 0 and t equals 1. We can go back to the line equations. You can do both as a check, but technically you only need one. Take this first one. We left that parameter t. And so we're going to take x equals t, y equals 2t, z equals 3t, and we're going to substitute t equals 1. And we get x equals 1, y is 2 times 1 or 2, z equals 3 times 1 or 3. And so guess what? We have the point 1, 2, 3. There's our point of intersection. We can also take this s equation, s equals 0, and guess what? We get x equals 0 plus 1, which is 1, and y equals negative 2 times 0 plus 2, which is 2. Z equals negative 0 plus 3, which is 3. So there we have the same point. 1, 2, 3, as expected. So if the lines are askew, what happens is you can solve two equations, but over here we might have like 5 equals 4. If two lines are askew, you can find where they're over top of each other. You can find an x-y coordinate, but then the two different z coordinates that come from here would be different, and so we couldn't solve it. If the lines coincided, that's another thing that would happen. If they coincided, actually the equations would disappear. You end up with something like 0 equals 0, and you really have the same line, which is entirely possible. So, okay, and that's all for this video.